Hello everybody, my name is Jose Ovando and today I'll talk about our research determination of the microRNAs target genes network in idiopathic pulmonary fibrosis. The idiopathic pulmonary fibrosis or IPF is an irreversible disease characterized by progressive loss of the ability of the lungs to effectively transport oxygen to the bloodstream due to scarring. Eventually, the lungs become hardened due to the fibrosis and stop working. The IPF is an aging-associated disease because it occurs in people older than 50, affecting more men than women, and approximately 200,000 people in the United States are affected by IPF, and this number is increased every year. The median survival time from diagnosis is 2 to 4 years, with a 5-year survival rate of approximately 30 to 50%, which makes IPF more rapidly lethal than many diseases, including breast, ovarian, and colorectal cancers. There is no cure for IPF, but a timely diagnosis is important for disease management. A longer delay in access to respiratory specialist care is associated with an increased risk of death. Besides a lung transplant, there is unfortunately no cure for IPF currently. However, there are disease management options for people with IPF, including FDA-approved medications, pulmonary rehabilitations, lifestyle modifications, and oxygen therapy. It is therefore necessary to make efforts to contribute to IPF research. The microRNA is the name of a family of molecules that help cells control of the kinds and amounts of proteins they make. That is, cells use the microRNAs to help control the gene expressions. The non-coding RNAs control gene expression mainly by binding with messenger RNA in the cell's cytoplasm instead of being translated quickly into a protein. The marked mRNA will be destroyed. Different microRNAs have been described in key genes and processes in the development of IPF, but their specific role in the disease needs to be further investigated. So, we decided to search and analyze the experiments stored in the Gene Expression Omnibus database of IPF lung biopsies and donors, and we included 8 microarray experiments and 2 RNA-seq ball experiments in our analysis, and we also used 2 microRNA expression microarrays to evaluate expression in downstream microRNA predictions, including a total of 304 IPF samples and 200 donor samples. And we performed the analysis for each experiment and platform separately, where the samples that present poor quality were excluded from our analysis. In addition, the differential expression analysis was performed using Lima for the microarrays and DSEQ2 for the RNA-seq experiments. Subsequently, we asked which genes were shared between experiments and platform. Well, this plot shows the number of intersections between the results of the differential expression analysis between the 8 experiments, and we obtained 152 genes shared between 4 or more experiments. However, we observed that genes coding for the adrenomedulin, the chemokine CCL2, and CD 163 did not have congruence in their expressions. When we remove the incongruent genes, we obtain 149 genes with a similar expressions state of regulate or don't regulate in each of the experiments, and these were used for the downstream analysis. And we can see that there was one gene that was present in all experiments, which was MMP7. These genes belong to the family of matrix metalloproteinase, and these proteins of this family are involved in the breakdown of the extracellular matrix in normal physiological process, such as embryonic development and tissue remodeling, which has been described as a market or IPF. This plot shows the top 25 of regulate genes in red and don't regulate genes in blue of the 149 shared genes, of which 89 were upregulate and 60 were don't regulate. Here we can see that many genes coding for collagens are upregulate, which are involved in the remodeling of the extracellular matrix, a key event in the progression of IPF. In addition, downregulate genes such as HHIP, which is a negative regulator in the hedgehog signaling pathway, and AGER, which has been associated with an accelerated disease onset. And the next step was the construction of a microRNAs target genes network in shared differential expression genes, and we used the miRNet database to obtain the predicted microRNAs previously described in lung with our core genes obtained from the previous analysis. The predictions show an interaction for 137 from the 149 input genes and 56 microRNAs previously reported experimentally in lung tissue, and the network was composed by 193 nodes and 769 edges. To better understand these results, we performed a module analysis using the wall-trap algorithm using SciFinder tool in Cytoscape, and obtained 5 main modules with genes associated with a specific biological process. The module 1 was composed of 41 genes which present an enrichment in 387 gene ontology biological processes such as tissue remodeling, angiogenesis, vascular development, epithelial development, and myofibroblast differentiation. In addition, 14 microRNAs are associated with this set of genes. On the other hand, the model 2 was associated with 13 gene ontology terms, including processes related to negative regulation of the cell growth, blood vessel remodeling, and response to hypoxia. The model 3 was associated with 153 gene ontology biological process, which encompass collagen metabolic process, organization and structure of the extracellular matrix, collagen fibrils, platelet activations, and the regulation of the epithelial-mesenchymal transition, key mechanisms described for the IPF. In addition, the Module 4 presents an enrichment in 84 processes in gene ontology terms related to the positive regulation of the development process, negative regulation of the cell communication and signal transduction, and the activation of leukocytes. Finally, Module 5 did not present any enriched biological process. However, genes such as MMP7, SPP1, and CTHRC1 were among the genes with a high degree of expression within the whole analysis, and other pro-fibrotic genes with a secretory function within the last model were COL5A2, MOC5B, and SERPINB5. In a specific way, the role of the microRNA 126.3p and microRNA 335.5p in IPF are unknown. However, studies have reported decreased level of these microRNAs in cardiac and renal fibrotic tissue, suggesting an involvement during the mesenchymal epithelial transition process through dynamic regulations. Similarly, in our work, we observe a downregulation of the microRNA 335.5p. Some work in murine models with bleomycin-induced pulmonary fibrosis have a report aberrant regulation of this microRNA, particularly in the Wnt signaling pathway. So in conclusion, and this is the first work that integrates, as far we know, all transcriptomic experiment on lung biopsies from IPF patients to find the gene signature related microRNAs, and we found 89 upregulate and 60 downregulate genes in IPF lung biopsies shared in 4 or more experiments on gene expressions showing as a signature of genes being consistently expressed in all IPF patients, and the top 10 predict microRNAs with the highest degree of the connection in the network are the ones we can see in the presentation. And finally, it's necessary to perform a more exhaustive search as a meta-analysis to know more in detail the effect of these microRNAs in the IPF. So thank you very much for your attention and continue to enjoy the conference.